So please start. SK, go ahead, sir.
Okay, ma'am. So do you start recording, ma'am?
Yes, sir. Yes, I had done.
Okay, ma'am. Okay. So good afternoon to all of you participants and organizers. Today is a very special day. You can say, because today we have with us a very young and renowned professor of Institute of Agricultural Sciences. So I take this opportunity to welcome our today's resource person. Today's resource person is Dr. Vinod Kumar Tripathi sir. Tripathi sir has obtained PhD from Indian Agricultural Research Institute, New Delhi. He has worked as ICR, Indian Institute of Water Management, Bhubaneswar, and Center for Water Engineering and Management at the Central University of Jharkhand, Ranchi. Presently, Dr. Tripathi is working as assistant professor at the Department of Agricultural Engineering, Banaras Hindu University, Varanasi. Dr. Tripathi has developed a methodology to improve the quality of produce with drip irrigation by utilizing poor quality water. So this is his today's talk is also. His area of interest is geoinformatics, hydraulics in micro irrigation, and development of sustainable water management technologies for higher crop and water productivity. Dr. Tripathi act as organizing secretary for 2 national and 2 international conferences. He had 46 peer-reviewed research publications in national and international journals with high impact factor, 8 books, 18 book chapters, bulletin, and attend several national and international conferences. He has received the Rekha Nandi and Bhupesh Nandi Prize from the Institutions of Engineers India, Kolkata, Jain Irrigation Award, and Distinguished Service Certificate Award from Indian Society of Agricultural Engineers, New Delhi. So, with these words, I welcome you, sir. Kindly come forward and deliver your talk, sir.
Thank you, Goel sahab, for nice introduction, and thanks for inviting me for this lecture and interact with the audience which are from the different part of the country. So, friends, Goel sahab, we can start, no?
Yeah, sure, sir.
Yeah. Friends, my topic which I have selected is that the utilization of poor quality water through the micro irrigation. So 2 aspects are connected here. Number 1, that yes, ma'am, any problem?
No, sir.
Please continue.
Okay. So 2 aspects are combined in this. Number 1, we have the water and it is utilized. And if you see in the industrial sector, domestic sectors, and in domestic sector, whatsoever water is utilized, around 80% of that water we are getting in form of the wastewater, which has the little poor quality. And in industries, which water is utilized, that is also coming as effluent, as a poor quality water, that we will call it as a wastewater. So these poor quality water is how it can be utilized, in which sector we can utilize. If you see domestic sector, its utilization for, you can say, drinking and or for using the domestic purposes, it requires so much treatment, and that will be the economically not beneficial for the use. So that's why still there is a, you can say, present days, there is a challenge that we have to, if we can develop the cost effective water treatment technologies. So those are those technologies which are cost effective is real need of the hour. If we can develop, it is a, you can say, $1 million question for every forum. So that's why it is, we can utilize these water in the area where there is a less chance of the contamination. So, and that we fulfill our the irrigation sector demand. So that's why on this topic I have selected to discuss with you. So in this second, if we see irrigation and agriculture, we can utilize the water in the irrigation area, and your irrigated agriculture has the much needed because of the global food production. While 20% of the world's farmland is irrigated till now, and it produces 40% of our food supply. It means you can understand the role of irrigation or role of the water which we are applying for the production of the crop. So higher yield we are obtaining in the irrigation because of the water gives the multiplicative enhancement in the yield response. So if we can go for the poor quality water, so these water contains different types of elements which are not desirable. Number one, we can go for the salt content that we can see in form of the salinity. Okay, these salt contents availability depends upon the geological formations and are the processes in which these water is utilized. If that process produces the salt, then that wastewater which is coming out, then in that case also it will become saline. Then water infiltration rate, because of the high sodium, low calcium content of the soil or water, reduces the rate of the water which enters into the soil due to the flocculating nature. So rate of infiltration is also reduces because of the these availability of the ions. Then we have some specific ion toxicity. Specific ion toxicity depends upon the different types of the industries. Some industries are giving specific particular ion, another industry is giving another type of ion toxicity region because of the different types of the processes involved for the utilization of the water, and their wastewater which is coming out, that is contains different types of specific toxicity. Then we can see here another type of problem which contains the poor quality water, that is the microbial contamination. These microorganisms, we can say bacteria, virus, helminths. These are the these microbes which are present in the water, and sometimes they are not visible by the naked eyes. So these microbial contamination is also present. So if we are going to utilize those water, so
Olhem,
these are
fica aqui. No suppose não. Tá aqui a hora
ma'am, any
antiga
problem?
hospital nem. Guess Mas com sorte é amanhã, mas didn't pagar o porto.
Okay.
मैम
ते
हामिदा
जरा
मैम
बेरोजगार की परेशानी छोटी की परेशानी थी तो उसी की
हामिदा
वजह से
मैम हामिदा
Okay,
मैम
जरा
I
चीजों
think
को
someone is
कैंसिल
talking,
हो
no
गया
problem.
है तो
So
बस
issue is that these
और
challenges we have to, when we have
टाइम
to
तो
plan the utilization of the poor quality water,
why not
we have to overcome how we can reduce the toxicity of these elements, these microbes. Reduction in the toxicity
omega
is the
6 no
main
pai nem vai
important issue
vai
for the
essa que
utilization
thirst
of this type of water.
thirsty então eu faço uma coisa também oxygen dioxide hello sir
जी मैम, हेलो.
सर प्लीज भी कंटिन्यू. वो मैम का माइक वहां
Okay.
ऑन था. उनकी
Oh,
मदर
okay,
एक्चुअली
okay.
ना हॉस्पिटल में है, so
Okay,
she is.
thank you, thank you. So, friends, if you see the consumption of water at in our India subcontinent, so irrigation sector is the highest consumer of water, and in after that you see our energy and industrial sector, energy sector. In energy sector, we have to see at most of the places, those are the thermal power plants are coming. So thermal power plants are operated, they are utilizing the steam because the steam turbines have the better efficiency in comparison to the other turbines. So in those sectors, that's why though the heat generated through the coals or through the radioactive reactions, so that heat produces the vapors, and that steam is utilized for the operation of the turbines. And in domestic sector, our day-to-day life, we are utilizing water, but highest consumer is the irrigation sector. So this is also the need of the hour. We can do something so that we can fulfill the irrigation sector demand. The reason in our, due to the development of the industries, due to the growth of the population, we are bound to divert more water towards the domestic sector and industrial sector. So if you divert more water towards the domestic and industrial sector, so definitely we have to reduce the water demand in the irrigation sector. This will be the challenge. So if you want to reduce the water demand in irrigation sector, so good quality water demand, so we have two options. Number one, we can utilize the water which is used in other sector, and we can utilize in irrigation sector as a wastewater. And second, we can enhance the efficiency. Means how we can enhance the efficiency of the irrigation sector. So if we can enhance, we can less quantity of water we can utilize for the more area through the advanced irrigation methods like the micro irrigation method. So that's why in this topic I have concentrated on two important aspects. Number one, utilization of poor quality water in the irrigation sector to fulfill the irrigation sector demand, and it will also helpful to fulfill the future requirement of the good quality water in the other sector like irrigation sector, industrial sector and the domestic sectors. So that's why in this topic we have taken the micro irrigation and the poor quality water. Then friends, if you see nowadays in India, this is the little poor old data, around 40 million liter wastewater is generated from in different part of the country. So if huge quantity of wastewater is generated, so how we can, and this is the old data I am telling, in future again due to the growth of the urbanization, if you see the world level, your urban population has crossed the rural population. So in world level, so what is the scenario? If more our world become more urban in comparison to the rural, so wastewater generation from the urban area will be higher, and government do not have much capacity to treat these wastewater at the individual level. So it gives the you can say different types of restrictions to the industries that they should treat this wastewater and give out of the industry, so that there will be less toxicity in the environment. Number one. Second, government is also planning, and somewhere in the industrial zone where the you see industrial area is there, those industrial area, government is making the plan for the common treatment plant. So in the common treatment plant, they are giving a certain level of the treatment to the wastewater which is generated from the different industries. So but much emphasis is on the industries because they are giving much polluted water. But in the domestic sector wastewater which is generated, is not much importance is given by the even government level or municipality level. Region, they are giving importance, but a certain level, because they are giving more priority to the industries, because they are giving the higher polluted water, which have the more contamination. So under this scenario, so we have the concern that which wastewater which is generated, we can utilize it in the irrigation sector. So number one, you can say good thing, that the quantitative terms. Quantity means we have the huge amount of the wastewater. And second, if wastewater will be utilized, then we will give some treatment to them. Otherwise, we will throw it into the environment. So if we will throw it into the environment, so it will create the environmental challenges, harm to our ecosystem. We have to clean it and utilize, so it will be economical. Otherwise, if we will just throw it, so it will create the environmental challenges. So that's why it is we want the quantitative, economically, environmentally, and socially sound planning for the utilization of the wastewater. And we have to see some public health standard in the utilization of these wastewater, so that what is the public health standard means, whatsoever where this water is going to utilize. Let's say we are utilizing for a particular crop, so we have to see what is the produce and the quality of the produce and the standard of that produce, different element available in the produce with the different standards. So that's why there is a need. We have to develop some public health standards. Some standards are already there to utilize this type of poor quality water, and in which crop we have to utilize, so that it will be less harmful for the people which are going to utilize that produce. So one of the primary treatment system for the poor quality water is which is feasible up to the, I'm not recommending those things which are can be utilized for the higher level industries. Higher level industries have the money, they can utilize different types of water treatment systems. But at the farmers level, for the irrigation sector, we have the limitation, means we can utilize the water up to a certain standard. Up to a certain level, we can do the treatment. Otherwise, we cannot utilize. So that's why one of the primary system for the treatment of this wastewater or poor quality water is the constructed wetland. In the constructed wetland, the main important aspect is the sedimentation. Means whatsoever higher weight or higher volume objects or elements or any type of impurities are available in the poor quality water, that can be settled. Means due to the action of gravity, it will settle down. So we can, first things we can see with the help of the sedimentation process. Then we can pass this water through the filters. Those filters are in the layers. So what happens if water will pass through the pore spaces of the these filters? So those pore spaces will create the hindrance to the flow of poor quality water. In that hindrance, some of the impurities which are attached, which are soluble, even insoluble in the water, those physical impurities will be objected by the pore spaces, and they will attach to the filter media. So filter media will, in this way, filter media will reduce the amount of impurities available in the poor quality water. So up to a certain level of the treatment, a certain level of purity, we can provide with the help of constructed wetlands. And in the constructed wetlands, we can see here that these chemical elements, there are some certain level of the reduction or percentage of the removal is possible through the constructed headlands, wetlands. In this, you can see ammonia can reduce by 10 to 30%, nitrate, phosphate, and these species are utilized for the constructed wetland purposes. Then if we can go for the reduction of the impurities up to a certain level, then we can use this water. We are advocating that we can use this water through the drip irrigation or micro irrigation system region. Why it is? Number one, because the micro irrigation systems has the higher water use efficiency. Second, if we can utilize these waters with the micro irrigation system, then what will happen? It will create minimum contact with the plant and the operators. So if there is a less or minimum contact, so the transfer of the contamination from water, a poor quality water, to the irrigator or any other, you can say the fruits or these things will be minimum. So that's why it is also advisable. Then if we are utilizing it, it will be better. We have to utilize this with the subsurface drip irrigation. And if it is coming in your mind that there will be a more cost involvement due to the use of the subsurface drip irrigation. So in that aspect, I want to say that you can visualize here in the surface irrigation on the top of the land surface, there is a wetting. So due to these wettings, there will be a scope or there is a germination of the weeds. But in subsurface drip irrigation, minimum, very less amount of water is coming on the top of the land surface. But more amount of water is available in the root zone. So what happens? The amount of weed which is growing under the subsurface irrigation will be less or minimum in comparison to the surface drip irrigation. So in this way, we can reduce the weeding cost also, weedicide cost also. So that cost we can divert for the even a 5 centimeter thickness spade or any implement which can make the depth of 15 centimeter from the land surface. It will be helpful and it will not have the much cost involvement and very good for the, you can say, protection from the contact of the wastewater to the irrigator and the produce. And third thing, that where this wastewater is utilized, if it will be flooded or it will be utilized on the surface, so there is a formation of the aerosols. And if those aerosols, if any people will living side of those irrigated field, he may get the bad smell. So, but if we can utilize this in case of subsurface drip irrigation, so such type of problem will not be generated. And last advantage is that it will restrict the runoff and the deep percolation. Means we can restrict the runoff of, you can say, and deep percolation of the water, because we are applying the limited amount of water. We are not only limited amount of water we are applying. So definitely it will reduce the deep percolation losses also. So, but the limitation that if we can utilize for the drip irrigation system, it requires very good filtration system. If filtration system will not be good, then water in the drip irrigation system, as you know, is coming from the emitters, and emitter has the very small diameter, you can say, path. So these foreign particles will be deposited in the path and clog the emitters. So to avoid that, we have to go for the very good filtration system. And those filtration systems requires the frequent cleaning of the filters, because if you will not clean the filters, then what will happen? Again, there will be much pressure on the pump, your energy requirement will be enhanced, and there will be a reduction in the water application rate. So that's why it is recommended for the utilization of the wastewater that we have to use the automatic cleaning of the filters. Filters are coming after certain hour of the operation, automatically they will go for the back flushing, and in the back flushing operation, the filters will be automatically cleaned. And another limitation is it is difficult to detect the detect and expensive to clean or replace the clogged emitters. So number of emitters clogging will be more in case of poor quality water in comparison to the fresh water. So definitely it will it is a challenge, and we have to reduce the such type of problem with the use of the better filtration system. And ultimately, if there is a clogging of the emitters, it will reduce the emission uniformity, and it requires high level of the investment systems, so that definitely at the initial level there will be more investment. So there is a for better filtration, there is a strategy which has been utilized, that we can use the gravel media filter and disc filter in the combination. And if you will use in combination, actually what is the advantage? Here the pore spaces between in the gravel media filter is bigger in comparison to the disc filters. In the disc filters, discs are there, those discs are stacked one over another. So these discs, between the disc, if water will pass, so the porosity or space between two discs is very small. So if even a soluble impurity will also be reduced up to a certain extent with the passage of the impurity through the disc filters or in between the disc in the disc filters. And we can utilize these waters for the experiment is conducted for surface, subsurface, and in the subsurface 15 centimeter and 30 centimeters. But better performance has been achieved in the subsurface placement of the emitters at 15 centimeter depth. And these are the physical and chemical impurities, but biological impurities, or you can say microorganisms which are available. So these counting of these microorganisms we can do to see the availability of microorganisms at the through the different methods. We can grow the colonies of the microorganisms on the augars, or we can utilize the total coliform by this MPN method uh, for the estimation of the impurities in terms of the microorganisms. And if these, one of the microorganism is the E. coli, what is the availability of the E. coli if we can utilize this water in the surface and subsurface drip irrigation system? So the availability of these E. coli with the surface and different depth we can see. If we can apply the water at the subsurface by placing the emitters at the 30 centimeter below the ground, ground means placed at some 30 centimeter depth. So we can see that the availability of the E. coli on the surface of the land is zero. Means E. coli is not detected on the surface of the land if we can place the emitters at 30 centimeter depth. And their availability is lower, or you can say moderate or less, in when we are placing the emitters at 15 centimeter depth. But highest availability of E. coli is available on the land surface if we are providing the water through the surface drip irrigation methods. These are the scenario which we have seen at the in the crop after the 15 days of the transplanting. But after 50 days of the transplanting, we can see that still there is no availability of the E. coli when we are placing the laterals at 30 centimeter depth, and there is not much enhancement in the E. coli if we are placing the laterals at 15 centimeter depth, means it is in the range of the 2 log value, and after 50 days also we can see there is a availability of the 2 log values. Means what happens that the population will is of microorganisms are growing up to a certain extent. After that, these population in the soil is not enhancing. Reason that it depends upon the availability of the nutrients for the growth of the microorganisms. Second, there is a certain limit. After that, there is a no enhancement in the population. So still we can see there is a no E. coli available when we are placing at 30 centimeter depth, but there is a at 15 centimeter depth, there is a availability of the E. coli at 2 log values, not more than that. Means after certain period, the population of the E. coli is, you can say, consolidated. There is no enhancement in the E. coli population after certain days of the irrigation. So this is the crop in which this water has been utilized. This is the produce. And if we can see what is the performance of the leaf area index by the different methods of the irrigation. D1 is the surface irrigation method, and D2 is the subsurface at 15 centimeter, and D3 is the subsurface and placement of lateral at 30 centimeter depth. So under this condition, we can see that initially the performance of the leaf area index is higher under the surface placed laterals. But after certain period, after 45 to 50 days, you can say after transplanting, we are getting the performance of the subsurface placed laterals. Means at 15 centimeter depth, subsurface placed laterals are giving better leaf area index in comparison to the other, you can say, treatments where we are placing the laterals at 15 centimeter depth, or we are placing it at surface in form of D1 and D2. If we see the performance of the yield, so yield in the different treatments, we can see there is a higher yield in the second year in comparison to the first year. Region, whatsoever nutrients are available in the wastewater or poor quality water that are accumulating in the soil and giving better results in the next years. And because these poor quality water at the municipal level contains different types of the nutrients, if we can see, we can save the fertilizers of NPK in terms of the 20 for the brinjal crop which had been, it has been, or you can say for eggplant has been calculated that it can save the fertilizers of 28% N, P is 21%, and K is 38%. So what is the advantage? That with the use of these poor quality water in terms of the wastewater, we can reduce the demand of fertilizers should be applied, because wastewater already contains some amount of the nutrients. So if we can see the availability of the toxic elements in the different treatments, so copper availability is what is the safe limit by the BIS, Bureau of Indian Standard, and the safe limit prescribed by the Codex standards. So we can see that in the all treatments, whether we have placed the laterals on the surface, subsurface 15 centimeter or subsurface 30 centimeters, those conditions we can see after 2 years of the experimentation, always there is a less copper availability is less than 40 milligram per kg, and you can say that is the safe limit for the utilization of the wastewater for the copper point of view. And safe limit in this way for the this iron is the 45 milligram per kg, and we can see these iron content, except one treatment, in all the treatments it is lower, but it is close to the 450 milligram per kg. Nowadays you see the fortification program is going on, that we can there is a ladies are lacking with the anemia, students at the small nurseries, they are also given the iron tablets. So if there is a more availability of iron, and not it is in such a extent that it will become toxic, so we can don't have the much you can say problem with the availability of more iron, number one. And second, some iron part are utilized for the drip irrigation systems, that also releases, because 2 year continuous same filters and those things has been utilized. So, and with the poor quality water which has the higher acidity, so definitely there is a release of the iron from the system, drip irrigation system, to the coming out the in form of through the emitters. So this iron content is not a big problem, you can say. So about lead content, we can see lead content is if 2.5 milligram per kg is there, then we can say it is safe. And here in the all treatments, there is a not lead content is not more than 1.3 milligram per kg. So it is good from the lead point of view, means there it will not create the toxicity. Similarly, for zinc also safe limit is 50 to 60 milligram per kg. These safe limits I have taken from the BIS standard, or for some elements BIS standards are there. For those elements there is no BIS standard. We have taken the Codex standard. Then there is a zinc 50 to 60 milligram per kg is the safe limit. Here, no any treatment contains more than 21 milligram per kg in any treatments. So we have to go for the health protection measures, and those health protection measures are requires if we are utilizing the wastewater for irrigation. Number one is the crop restrictions. We can see the different types of crops are coming. Some crops are taken or eaten as a raw, and some crops are eaten after boiling. Some crops are giving some produce like your mustard. It gives the produce which will be coming out after the speller, and then it will again go for the you can say high degree treatments for the utilization of the vegetable oils. So that's why we have to, there are some crop restrictions. So generally for the crop restriction point of view, it is recommended that those crops, those produce which has been eaten raw, is not advisable to irrigate with the poor quality water. So either we have to irrigate with the poor quality water, or we have to not utilize those poor quality water in the crops which are eaten as a raw material, which are we are utilizing for the salad purpose and all those things. Generally we have to restrict it. Then wastewater application technique. So here one thing that we have to utilize such a application method so that our crop will grow. We can fulfill the irrigation demand, but we have to apply limited amount of water, because these water which contains the impurity, and if impurity will be applied to the soil, so definitely it will be accumulated in the soil. So in the long run, after 20-30 years of continuous application, this may create problem, and there is a need to study the impact of the long-term studies of poor quality water on the soil under the different methods. So, and third aspect we can see that the health protection measure is the pathogen die-off. Means if some pathogens, some microorganisms, let's say, enter into the plant system. So it is not necessary that after entry into the plant system, they will survive up to a longer period. They will die off after certain period. Let's say in some plants they are surviving for 1 week. Some plants they are surviving for 10 days or 15 days. So what we have to do, that we have to stop the poor quality water irrigation before the die-off period. Let's say die-off period is 15 days. And so before the 15 days, we have to stop the poor quality water irrigation. And if there is a need of again irrigation, and so we can apply the good quality water so that we can get the health protection. And food preparation measures. we have to see, we have to apply the washing, means good quality washing we have to do. Then disinfectant we have to use, peel the produce, so that whatsoever microorganisms are available over the surface, they will go out. We have to cook the material properly, so whatsoever microorganisms are available, they will be dying over the higher temperature in the process of cooking. Then human exposure control. You can see bacteria, virus, they can enter into the human body from any naked portion. Our hand is open, naked, our face is naked. So under these conditions, these microorganisms can enter into the body. So we have to reduce the human exposure, so that we have to provide some control. And then wastewater treatment we have to do. And then combination of these measures depends upon the labor, fund, land, water, social and cultural practices. It is not necessary that all the practices is possible to apply at one place. So in the combination, if we can apply, it will be helpful. So if you come to the conclusion of this study, that with the combination filters improves the constructed wetland, and use of combination of filters. Drip irrigation filters means you can say gravel media filter and disc filters. If we can utilize in the combination, so it gives the better performance. We can get more clean water, better emission uniformity, less clogging of the emitters, and high leaf area index we are getting when the placing the laterals at 15 centimeter depth, because of the better utilization of the nutrients, more utilization of the water, and better root volume. More root volume will be under the wetted condition, so it will provide the more nutrient intake capacity for the plant. And here we can see by if eggplant, this experiment has been conducted, so it will give the 7.6% higher wastewater in higher yield in comparison to groundwater irrigated plot, and we can save the 28% nitrogen, 21% phosphorus, and 38% of the potassium application for the better, you can say less amount of nutrients will be required to fulfill the crop demand. So, and heavy metal content which are available in the poor quality water, we can see these 4 specific type of nutrients, these toxic elements, they have less availability in the produce, and they are better and within the control of the prescribed limit by the different national and international standards, except iron, because iron is also required. We are doing the different programs to enhance the iron in the ladies and the children's. So this is the things, friends. So if we can utilize the wastewater, so we can save the water for our generations which are coming, and we can make it from waste to wealth, and we can make it as a asset. Thank you. Thank you, friends.
So thank you, sir.
Goel Saab.
Yes, sir. Ma'am Hamida Khanam, ma'am, please unmute the participants so they can ask questions. Participants, if you are not able to unmute your mic, then please you can write the question in chat box. So I will, sir can directly see your question
Yes,
and slide.
I am able to see the chat box. I think if anybody will write the question, definitely I will give the answer.
Please, participants. Okay. If there is no question, so it is a very good lecture, sir. Actually, you have finished your talk within a time. We have a standard time, 1 hour. Oh, sorry, 40 minutes for. Yeah, someone is writing, sir. Amit Biswas.
Actually, Amit Biswas ji, what are the possible wastewater treatment technology? There are, you can say, there are a lot of technologies are there. But what I have given here exposure. One thing that we can go for the constructed wetlands. Then we have to utilize the water for the filtration systems. We can utilize the combination filters. And in the constructed wetlands, I have told that we have to go for the gravity filtration, means foreign particles which have higher the weight, they can settle down. And second, if we will pass through the filters, so in the porous spaces, some impurities will be prevented. So in this way, we can utilize for the irrigation purpose. And because in the drip irrigation system, we are applying limited amount of water, so the contamination amount reaching in the root volume is less. So it will be not going much to the produce level. So this is one question. Any other question, Biswasa?
Please ask the questions. Actually, the faculty of BHU, they are very. I have no words for them. Now, actually, they are very knowledgeable persons, and they are. Yeah, another question, sir. Any possibilities of?
Any possibilities of bioadsorbents? You see, different types of species are there. Those species, you can say, we don't have such a concrete technology. I can say we can directly